Hi everyone, welcome team, you're doing a great job, well done team. So we're on theme 5, we're going to look at four little different subtopics within theme 5 in this video. So the first section of the video is going to be on the natural causes of climate change. That's going to focus on the Milankovitch cycles. The second part of the video is going to focus on the global atmospheric circulation, so the intertropical convergence zone. The third part is going to be factors affecting UK weather, like urban microclimates, latitude, altitude. And the fourth section of this video is going to be high pressure weather systems. So thank you all for joining me and well done, you're doing a brilliant job. Okay, so the first part of this video is on the natural causes of climate change. Now, one of the natural causes of climate change, of course, is volcanic activity, making the climate actually cooler for a number of years. Now, I'm not going to focus on that with you, but it is in your revision guide if you want to go over that. So for the natural causes of climate change, volcanoes do count, but for this part of the clip, I'm going to look at the Milankovitch cycles. Okay, so here we are with the Milankovitch cycles. Now, if you forget the word Milankovitch in the exam, it doesn't matter at all. If you explain the cycles, that's all that matters, okay? Similarly to the first part of the Milankovitch cycle is the theory of eccentricity. Now again, if you forget the word eccentricity in the exam and you talk about circle to egg shape, then that's perfectly fine, okay? So the theory of eccentricity is the idea that the Earth isn't always in a circular orbit around the Sun. If it was in a circular orbit around the Sun, it would always get the same amount of radiation, the same amount of heat, because it's always the same distance away. But in fact, eccentricity suggests that the orbit is more of an egg shape, if you like. And that means when it's here, it's getting the same amount of heat. But actually, when it's here, it's getting a little bit less. And when it's here, well, that could explain the ice ages, because it's so far away from the sun that it is getting less radiation, so less heat. I apologise for the when it goes a little bit grainy. So eccentricity is the theory that the Earth doesn't have a circular orbit around the Sun. Okay? If it did, it would get the same amount of radiation all the way around. But in fact, sometimes it's what we could call egg-shaped. So sometimes it's further away from the sun. And when it's further away, because the sun's rays and the energy have got so far to travel, it's colder because the radiation has obviously got further to travel. Okay, so the first natural cause of climate change is the idea of eccentricity, that the Earth isn't going in a circle around the sun on its orbit, it's actually going in an egg shape, and that means that at points it's way further away from the sun, so it's colder because the radiation has got way further to travel before it hits the Earth. That's the first one. The second one is the tilt. Now obviously we tilt towards and we tilt away, but this is saying that actually sometimes when we tilt towards or away, there is actually degrees of difference in that tilt. So sometimes the tilt will be further away than others, and if it's further away, it's going to, and likewise if it's closer, okay, so if it's closer, if the tilt is closer towards the sun, it's going to be warmer. And if the tilt is further away from the sun, it's going to be colder, because the radiation has got further to travel before it hits the Earth, okay? So the theory of the tilt is that if it's tilting towards the sun, it's going, or even tilting degrees further towards it, it's going to be warmer because it's closer. If it's tilting further away, the sun's got further to travel, so it's going to be colder, right? And the last one is the wobble. The idea that actually while we're orbiting the sun, moving around, that our Earth has got a natural wobble. And obviously if it wobbles away from the sun, it's going to be colder. If it wobbles towards the sun, it's going to be hotter. So as well as volcanic eruptions, there is also eccentricity, tilt and wobble. And if you forgot eccentricity in the exam and just said it goes from a circular orbit to an egg-shaped, then you're still getting the marks, okay? Well done. Okay, so in this section, we're going to look at global atmospheric circulation. Okay, global atmospheric circulation, including the intertropical convergence zone. I think a lot of you find this quite confusing, and you look at it and you find it daunting. But don't panic. I'm going to take you step by step through it. And I promise you, if you really think about it, it will all become clear. And remember, you can stop, rewind, go over it again if there's anything that you don't understand, okay? So the global atmospheric circulation. Now, before we look at it in any sort of detail, we need to, first of all, just refresh our minds on high pressure and low pressure. So before we look at anything, we just need to refresh our minds on high pressure and low pressure, okay? This is like step one of understanding. So, in a high pressure situation, the air is pushing down, okay? So in a high pressure situation, the weather is pushing down. We're under high pressure. If there was a person here, the air, actually Neville, we haven't drawn Neville in ages, there's Neville. The air is pushing down on Neville. So you can't physically feel it really, but imagine like the person is buckling under the pressure of the air pushing down. In a low pressure situation, good old Nev, unsung hero, isn't feeling the pressure, because in a low pressure situation, the air is going up, is rising, okay? So in a high pressure situation, the air is pushing down, low pressure, it's going up. In a low pressure situation then, that is encouraging evaporation, okay? Evaporation is being encouraged because the air is rising. And because evaporation is being encouraged, you often get cloudy, wet weather, rain. And funnily enough, the UK suffers a lot from low pressure. So because it's moving up, increased evaporation, you get clouds and rain. So low pressure systems generally mean rain, okay? It could be convectional rain, but it is rain. High pressure systems, the air is pushing down, so there is not a lot of evaporation, so you have sunny conditions. There's not a lot of evaporation, you have sunny conditions in a high pressure system. So in order to understand the intertropical convergence zone, you first need to understand high pressure is pushing down, sunshine. Low pressure, air is going up, increased evaporation, clouds and rain. Okay, that's step one. Now, this is the bit where I think we'll panic, but you need to not. Just focus, listen, and hopefully it will become clear. So, on our world, we've got the equator and the tropics. Now, at the equator, we have a low pressure system, okay? So at the equator, it is low pressure. So what that means, there's actually convectional rainfall. And if you look at the Savannah video, you'll see a recap on convectional rainfall. But basically, the sun is heating up the ground, which heats up the trees and the water, and it causes mass amounts of evaporation and transpiration. You get clouds, and then it rains. So because on the equator, there is a low pressure system. The air is rising, there's increased evaporation and transpiration from trees, creates clouds, and it rains. So at the equator, it is raining regularly on a daily basis. And as a result of that, you get the tropical rainforest where it's really, really wet. So step one, the air is rising at the equator. It is low pressure. Step one, air rising at the equator, okay? And that creates rain. There we go. Now, that is going to get up to here. This is the, like the tropopause is the line where it's not going to go any further than that. So it rises, and if you don't know tropopause, it doesn't matter. But it rises essentially up to the atmosphere, okay? So when it gets to the atmosphere, or tropopause, it spreads out. It goes north and it goes south, the air does. Now, because it's come up and across, what goes up must come down. So the air comes over here and it goes down here, okay? It comes along here and it goes down here at the Tropic of Capricorn and the Tropic of Cancer. And if you remember, where the air is going down, you have high pressure, so it is extremely hot. So step two, air spreads north and south, okay? Step three, what goes up must come down. So the air, because it cools, it gets heavy, it sinks down, or it goes back down, okay, at the Tropic of Cancer and the Tropic of Capricorn. And that creates hot weather, which leads to desert, right? So, put simply then, the air is rising at the equator, creating rain. It then spreads north and south when it gets to the tropopause. It must sink back down again. So when it gets to the tropics, it sinks back down, creating high pressure, hot. That's why you have tropical rainforest here, desert there, because it's really wet here, it's really dry there. Now this whole cell is called the Hadley cell. So this whole process, this section is called the Hadley cell. So hopefully that makes sense, right? And where the air meets back here is the intertropical convergence zone. Where the air meets back is the intertropical convergence zone. But that's the explanation of the process. That's the bit that I would focus on, okay? It's a bit that I would focus on. So if I just borrow the WJC revision guide a second, this is where the Hadley cell is happening. So the air is rising here, and you're getting rain, spreading north, spreading south, and is sinking back down again, where you get sunshine, and then it goes back round. So this is the intertropical convergence zone, and these are the Hadley cells, okay? Now there's also the feral cell and the polar cell. Feral cell, polar cell. These are less distinct, less prominent. This one is the one that is most important, okay? But just so you know, after the Hadley cell, there's the feral cell and the polar cell, but they are less distinct or less important. Now, if you're having any problems with this, I would pause, rewind, and go back through, okay? but the air rises and rains, spreads north and south, and because it's colder, it sinks back down again, and that's hot there because it's high pressure. So if you need to, I would go back to the beginning and just have a look over it. But this whole thing, this is the intertropical convergence zone where the airs are meeting, and the name of the cell is the Hadley cell. Okay, well done. Okay, so the next section then on factors affecting UK weather. So what factors affect the weather in the UK in this section? I'm going to use the world map, sorry, not the world map. I'm going to use a map with the UK in it for 3 of them, and then go through 3 more. So, first thing that affects the UK is the ocean currents. Now, to explain it simply, so first factor is the ocean, oh blimey, ocean currents. Now what happens here is the ocean brings up via North Atlantic drift, it brings warmer waters from the south. So it brings warmer water to the UK, okay? So it comes up from Gulf of Mexico, comes up through North Atlantic drift to the UK. Now this warmer water is why we have a mild climate, okay? If you've been to Central Europe in the summer, it's way hotter, and in the winter it's way colder than us, even though we're on the same line of latitude. The reason being, our ocean gives us our mild climate. It means it doesn't get too hot for us in the summer, doesn't get too cold for us in the winter. So that's the first point to remember, is that ocean currents affect us. If an essay question did come up on factors that affect the UK and it was like 6 marks, if you talked about 2 exceptionally well or 3 well, then you'd get your 6 marks. So you don't need to remember all of these necessarily, okay? But that's ocean currents. Another one is the latitude, so where we actually are in the UK. So we know, if I just write here, hang on, sorry, latitude. We know that from the curvature of the Earth, it matters if you are here or here. If you are at point A by the equator, the sun has got less distance to travel, but also the sun ray has a smaller area to heat. Whereas if you're at B, it's got further to travel, and because of the curvature of the Earth, the sun ray has got a bigger surface area to heat than it does at A. So it's colder. Well, that matters then. So if you are to the south of the UK, because you're closer to the equator, it's actually slightly warmer, and in the north of the UK it's slightly colder due to being further away from the equator. Okay, so the second thing to think about is the latitude. Now the final one I'm going to talk to you about around this map is the air masses. Now the UK is impacted by 5 air masses. That's important because where air masses meet, you get areas of low pressure, so you get rain. Now there's 5 air masses meeting over the UK, so that is a lot of low pressure systems, aka a lot of rain, which may not surprise you. Now, for the benefit of this, I'm just going to get my little never eat shredded wheat compass. There we are. Okay. Oh, lost the north. There we are. Never eat shredded wheat. So, the 5 air masses, if you don't remember these, I don't think it's the end of the world, but it's worth going over them definitely, because you never know. So, we get 5 different airs coming in. Okay. Now, we get 1 air mass coming in from the north. Okay, this air mass coming in from the north brings cold weather. And actually, in winter, it brings snow. But the reason why I say, hopefully you could put 2 and 2 together in the exam and think, if it's coming from the north, well, the north is freezing, ice covered, that's going to bring cold air and snow in winter. Okay, so if you think logically, you think it's coming from the north, and you think what the north's like, hopefully it will make it easier. Now, we also get affected from the east. Now, knowing what we know about how Europe's temperature is, that brings, the one from the east brings hot temperatures in summer, and it brings cold temperatures in winter. So similarly to the temperature in Europe. Then we have our southeasterly, coming from closer to the equator. So it brings hot, dry. It's dry because it's coming over the land. So it's coming over the land, so it's dry, and it's hot because it's coming from nearer the equator. Now, southwesterly, we already talked about this being mild because of the sea. So it brings mild weather, but it is wet because it's travelling over the ocean to get to us. So mild, wet weather. And then northwesterly brings cold weather because it's coming from the north, it's freezing. And it's also can be like showery, wet. If I put showery, like wet, rains. Hopefully you can see that actually a lot of that would be common sense if you went through the thought process. Coming through from the north, it's cold, snowy. Coming from the east, same temperature as the east gets, hot and cold. Coming from the southeast, closer to the equator, hot and dry. Coming over the ocean, it's mild, linked to the ocean currents, but it is wet. And then from the northwest, again, it's cold because it's coming from the north, and showery. So those are the first 3 factors: ocean currents, latitude, and air masses. There is also, let me think about this. There's also altitude, okay? So altitude. So here's my hill, okay? If Neville stood here, it's going to be warmer than it is up the top of the hill, because, or mountain, because as you go up a mountain or increase in height, for every 200 meters you go up, there is a 1 degree Celsius drop in temperature. So the higher you go up a hill or a mountain, the colder it gets. If you think, if you've been up Penavan, you might be sweating, taking your layers off all the way up, but actually when you get to the top, it's quite cold, because every 200 meters up, there's a 1 degree decrease in temperature. So altitude can affect temperature in the UK depending on whether it's a hilly area or not. Another thing that can affect it is aspect. Aspect means the way it's facing. So for example, if a hill or a house is south facing, it's going to be warmer. So if anything is south facing, it's going to be warmer, it's going to get the maximum amount of sunlight, okay? And then the last factor is quite a big one. I might dedicate the back of the sheet to it actually. Quite a big one, okay? It's called urban microclimates. There we are. So last factor affecting UK weather, urban microclimates. Right, if you think about it, you've got your one-off house in your countryside over here. If you think about what your city's like, here's my attempt at a city skyline now. This is going to be sheer genius. Here we are. So, yeah, brilliant. Windows. If you think about your city the way it is, right, I have to stop now, otherwise it's going to take too long. But and your roads. Your city is made of concrete. Now the concrete absorbs heat, okay? It absorbs heat, Not only that, but you've got densely populated area. Oh, what's my spelling gone there? You've got densely populated area. And all those people, not only have they got body heat, but they're using central heating, they're driving cars. All of that generates heat, okay? So that generated heat is called an urban heat island. So it may actually be warmer in the city than it is in the countryside, and you may have experienced this, like if you've gone to London in the summer holidays, I always find it boiling compared to anywhere else. That's an urban heat island. Now, because of all these tall buildings, they also protect from the wind. So it is also less windy in urban areas because they're protected from the wind by all the tall buildings. On the other hand, though, you could get increased convectional rain, because yet again, we know that if it's really, really hot at ground level, it's going to increase the amount of evaporation, condensation, and then rain. So you can actually get you can get more rainfall in an urban microclimate because of convectional rain. Okay, so it's hotter, less windy, there could be a little bit more rainfall. Okay, well done. So last section of this video then is on high pressure weather systems. High pressure weather systems. You might actually find this quite straightforward because we've just looked at the intertropical convergence zone, and this is within it. So high pressure weather systems, as we discussed earlier, is where the air is pushing down. It's coming down. Because it's coming down, there is not a lot of evaporation. So it is hot and dry. Oops, dry. Now this can actually lead to a drought or a heat wave. Okay, so this is going to lead to a drought or a heat wave. Now that's all you need to know really about high pressure systems. Air sinking, it's hot, so it creates hot and dry weather like a drought or a heat wave. We actually looked at a little example of this. We looked at the California drought from 2012 to 2015, at which point a high pressure system blocked out the low pressure system. So the high pressure system sat over California and stopped the low pressure system from getting in, so there was no rainfall. Now the impacts of that then we'll go over. We'll also go over the responses to that. So in terms of the impacts then, there was hydroelectric power in dams that stopped being produced. So there was no hydroelectric power being created, or very little, from dams because there wasn't enough water in the dams in the first place. Not only that, but crop failure. There wasn't enough water to water the crops, as we know. Remember, we watched the video about the farmer who had no access to water, and that meant less food. And because there's less food, it meant increase in food prices. Because there was less of it to go round, it meant that food prices actually went up. Not only that, but 17,000 farmers or agricultural workers lost their jobs. Agriculture is the same word for farming, remember? So 17,000 agricultural farmers lost their jobs. Not only that, but salmon and trout died. The reason why salmon and trout died is because there was so much less water that the little water that there was being really easily heated up. So the temperature of the water was rising so much that the salmon and the trout couldn't survive. Also, underground aquifers or underground water stores, underground water stores or aquifers were drained, which means in the long run then they've got an even bigger problem, because not only have they not got any water now, but the water source that they used to use is now gone. So the underground aquifers haven't recharged, haven't filled back up with water, so they're going to have this problem with the lack of water for a long time. Ways that they dealt with this, then, we looked at Twitter shaming by the hashtag when people used their hose pipes. But also, that all came about because there was a compulsory water restriction. So people were not allowed to use water to clean their cars. They were not allowed to use water to water their gardens. It was banned, right? Also, in California, toilets, washing machines, anything that uses excessive amounts of water has to be modern technology. Okay, it has to be modern technology for low water technology to try and prevent wastage of water. Also, some farmers did start growing drought-resistant crops. That means crops that can grow even when there isn't a lot of water. But that does mean changing a lot, and they're more expensive. Okay, so there's the impacts and response of the California drought, which is an example of a high pressure, the impacts of a high pressure weather system. Okay, so that brings us to the end of this video. Well done, everybody. Your effort that you're putting into these exams is exceptional. Good for you. Well done.